All right, today we are still looking at scientific notation. So our first question here says that the answer on our calculator screen shows up at in the box below. What's another way we could write our answer? This is a review from yesterday. We said that number in front with the decimal will stay the number in front, making sure it's between 1 and 10. Then we multiply by 10, and the number after the e is the exponent. So our exponent would be -8 for this one. So this is what our calculator will show if we're dealing with a number in scientific notation. Today, the new part is figuring out how many times bigger something is than something else. So in this box, we're going to write 3 steps. The first step is to find how many times larger. Find how many times larger is the front number by dividing the front two numbers. So by dividing the front numbers, using my abbreviation for numbers. Our second step will be to find how many more tens are in the larger number. How many more tens are in the larger number? And our third step will be to multiply both parts to get our total. Multiply both parts to get our total. So here is an example. It says, how many times larger is 6 times 10 to the 5th than 2 times 10 to the 3rd? So the way we tell which one is the biggest one is whichever one has the biggest exponent. So I'm going to write that over here, that the bigger number is the one with largest exponent. So if I am looking at these two, then I can see that this one over here on the left, 6 times 10 to the 5th, is going to be the larger number. So my first step said to find how many times bigger the larger is in the front numbers by dividing the front numbers. So I'm going to do 6 divided by 2, or maybe I already know in my head that 6 is 3 times larger. So I'm going to write my work right here, 6 divided by 2. That front number is 3 times as big. Then I'm supposed to figure out how many more tens are in the larger number. So this one, the front number has 5 tens multiplied, and the second number has 3 tens multiplied by each other. So there are 2 more tens. So I'm going to write 10 to the second. That is how much more is in the first number. And I know that 10 times 10, 10 to the second, is 100. So the back number is 100 times bigger. Now I'm supposed to multiply both parts together. So 3 for the front numbers and 100 for the second number. I get 300 times larger. That first number is 300 times as big as the second number, even though they look the same to me. It's 300 times bigger. Let's try another one. If I look at my next two, I have to figure out first which one is the bigger one. And it is going to be the one on the right, because -1 is a bigger number than -4, that exponent. It's closer to 0. So I need to figure out the front number, how much bigger is 8.9 than 4.15. So I'm going to write 8.9 divide by 4.15, And my calculator is going to tell me that that is about 2.14 times as big. Then my bottom, I need to see how many more 10s there are. So -4 and -1 are 3 apart on the number line. So that means there are 3 more 10s in 10 to the -1. And I'm supposed to do 10 times 10 times 10, and I figure out that means that it's 1,000 times bigger. So I need to multiply my two parts together, 2.14 times 1,000, and I would get 2140. So it's 2,140 times larger for my second example. Let's move on. On the back, it says the diameter of the moon is approximately 3.5 times 10 to the 3rd kilometers. The diameter of Earth is 1.295 times 10 to the 4 kilometer. How many times larger is the diameter of the Earth than the diameter of the moon? So it's multiple choice. We want to just circle one right away, but we know that we shouldn't. We should show our work. So Earth, it says, is larger. So 1.295 times 10 to the 4, and then the moon is 3.5 times 10 to the 3rd. So I'm going to divide my front two numbers, 1.295 divided by 3.5, and I find that that is 0.37. Then the larger number has one more 10, and 10 to the 1 is just 10. So I multiply my two numbers together, 0.37 times 10, and I get 3.7 times larger. So my answer should be D. Let's look at the next one. This one says the average distance between Earth and the Sun is 93 million miles. The average distance between Jupiter and the Sun is 484 million miles. The distance between Pluto and the Sun is 3,675 million miles. Part A says, how many times farther from the Sun is Jupiter than the Earth? So Jupiter is our larger one, and Earth is our smaller one. Here's the problem. They're not in scientific notation, so I don't know how to do them. But I do know how to turn them into scientific notation, so I'm going to write down that I need to make them scientific notation. So let me write down what Jupiter is. 4, 8, 4, and 6 zeros. So my decimal point is not there, which means it's at the end. And it needs to move between the 4 and the 8 to be between 1 and 10. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8. It moved 8 times. So Jupiter is 4.84 times 10 to the 8. It's positive 8 because it is a large number. Now I need to change Earth to scientific notation. It was 93 and then 6 zeros. So again, my decimal point is starting at the back. It needs to move between 9 and 3. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So Earth is 9.3 times 10 to the 7. Now I can see how much larger they are. So I divide 4.84 divided by 0.93, and I get 0.52. And then 10.8 has one more 10 than 10 to the 7, and 10 to the 1 is 10. So I multiply my two numbers, 0.52 times 10, and I get 5.2 times farther. So Jupiter is about 5 times farther away from the Sun than the Earth is. Now let's look at part 2. Part 2 says how many times farther is Pluto? So Pluto was 3,675 and then 6 zeros. And I need to change it to scientific notation. So I put my decimal point at the end, and it needs to go between the 3 and the 6. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So Pluto is 3.675 times 10 to the 9, positive 9. Earth, I already did Earth. I did it above. Earth was 9.3 times 10 to the 7. So I compare my front numbers, 3.675 0.75 divided by 9.3, and that is 0.395. Then my tens, Pluto has 2 more tens, and 10 squared, 10 times 10 is 100. So when I multiply my numbers, I get 0.395 times 100, and that would be 39.5 times farther. So Pluto is almost 40 times as far away from the sun as Earth is.